In this class, when we've analyzed how an object has deformed under stress, we've always assumed that it was deforming under stress elastically, meaning that if I release the force that this object is under, it'll return back to its original shape, and that it more or less obeys Hooke's law. But we know that if I pull too hard on this object, it'll start to permanently deform, or we say deform plastically. As mechanical engineers, we refer to any plastic deformation in some sense as a failure of the object. And the stress that causes this object to begin to permanently deform, we refer to as the yield stress for this object. One of the principal reasons we as mechanical engineers do finite element analysis is to determine if the actual stresses inside of our object are anywhere near our yield stress. But remember, in the last video, I reminded you that our stress is not a single number that we can compare to our yield stress, which is a property of the material. It has 6 different components. I only find a single scalar value for stress once I determine a plane at which I am calculating the stress normal to that plane. We're used to looking at an object under stress or with forces applied and assuming that I can determine the stress, and we've been thinking along planes that are normal to the forces that are applied. But I could pick a different plane, and because this different plane has a different cross-sectional area through the body of interest, and because the angle that this makes with the force will be different, there will be a different stress if I select this angle versus this angle, or whether I selected that angle. So now, in order to compare the stress inside my object to the yield stress of the material the object is made out of, I need a single component, or I need to find some single scalar value of stress to compare to my yield stress. There's a couple of different stresses we could look at. We could look at the stress for the plane that causes the maximum amount of stress in my object. That is called the first principle stress. You can calculate that stress using this formula here that you probably remember from your mechanics of material class. There's another principal stress called the second principal stress. The formula is the same, except for this plus sign is now a minus sign. This is the plane that causes the minimum amount of stress in a two-dimensional problem. There's also a third principal stress, but we won't worry about that in this class because all of the analysis we will be doing will be modeling as two-dimensional. Despite the fact that the first principal stress represents the maximum stress in the object, it is not the first principal stress that's normally used to compare to the yield stress of the material of the object is made of. Rather, a stress called the von Mises stress is more commonly used. The formula for determining the von Mises stress for an object that's being modeled as a two-dimensional object, whether it be modeled as plane stress or plane strain, is this equation here. Now, in the last few videos, we've reviewed a lot of material that you learned in mechanics of materials. If it's been a while since you've taken mechanics of materials and you think you need more of a refresher of the material you learned in that course, I encourage you to check out this website, which has some excellent movies and material and lecture material to really quickly get you back up to speed in mechanics of materials that you need for understand the material that follows.